Hello, everyone. It looks like it's my turn, I guess, right? Yeah. So let's talk about generative AI in practice. And we'll create, I'll show you a couple of demos, some concrete large language model use cases, but using Java or Groovy, actually. So I've put Java in the title, but there will be some Groovy for those who know me. Being the founder of the Groovy language. And I will be showing you the PaLM API. So the PaLM API, that is that API, that large language model, that powers Bard, among other things. So I'm Guillaume Laforge, I'm a developer advocate for Google Cloud, and of course you can follow me on Twitter, on Mastodon, and elsewhere. Yes. So I'll start quickly with a few notions and vocabulary, but I'm pretty sure you've seen that already in other similar sessions because that's a hot topic. So we're talking about artificial intelligence, but there are, different, like it's my potato diagram. There are different categories of artificial intelligence. You've got machine learning, then you've got deep learning, where you use neural networks to compute and predict and do stuff. And data science is more than just artificial intelligence because there's statistics and all sorts of math, but not necessarily mimicking the intelligence of human beings, And we're focusing today on generative AI, but more specifically on large language models, which are based on an architecture of neural networks, which is called transformers, which powers, at least today, all the large language models. So whether you're using some GPT model, etc., it's the same approach that is used under the hood with the same, or with some tweaks, of course, but similar architectures of neural networks. And so I'm not going to speak about imaging. Yeah, it's supposed to be pronounced imaging, image gen. I'll focus on the text generation using large language models, which is part of the bigger area, which is NLP, natural language processing. Okay. And as I said, it's based on a special architecture of neural networks, transformers, and that was something that Google created, Google Research and DeepMind. I forget which team inside Google invented that, but it's what allowed all the, this big, ecosystem of large language models, of startups, etc., and all the cool tools we can use today. And then there are other innovations along the way to further improve things. So what are large language models? So that's a neural network based on this transformer architecture. And the goal of those models is to recognize, to predict, to generate human language, to understand. I'm still a bit reluctant to saying understanding because it feels like, you're speaking of some kind of human being, sentient being, but it's not the case. But understanding in the sense of making sense of how words relate together in a statistical fashion. And some more vocabulary, let's say, we often speak about parameters and tokens when we describe large language models. So for example, PaLM, the one I'm using today, has learned 340 billion parameters. That's basically let's say, the number of neurons the system has. And it's also equivalent to its memory, if you will. And it's trained on tokens. Tokens are like words, but smaller parts of words. So usually, when we say it's been trained on 3.6 trillions of tokens, that's like 10 trillion of words in English, let's say. Usually a token, need 3 tokens per word or something like this. I forget the exact math. So that means that when the model was trained, so it took weeks and if not months, I don't know exactly how much time it took, but it read, so that's 3.6 million billions of tokens, or let's say 10 million billion words, which is enormous, right? I suppose you haven't read as many books, but at least it needs that many books to be good enough. And basically, yeah, the idea is that it's able to figure out the statistical relationships between the words, the phrases, and notice that even the same word like interest, are you showing interest about something, or are you talking about interest rates? But it's able to figure out, in terms of the context that is surrounding the word, that this interest word is a different interest word in the other context. And such models can then be further fine-tuned, which means, again, another word in our vocabulary, to further customize the model with a particular domain. So the PaLM model has been trained as well for the medical domain and security domain, etc. So you can further customize the model, and it's called fine-tuning. There are a bunch of model and model sizes. PaLM is one of the biggest. GPT-4, they didn't mention the actual number of parameters that they have, but it's certainly a big ball in this diagram. And I've put the link if you want to have a closer look at this. And there's really an explosion of models. And when I say this, talking about statistical relationships between words, there was also an interesting paper on which was qualifying large language models, comparing them to parrots, stochastic parrots, statistical parrots, in the sense that they mimic what they read, but they don't necessarily understand what they read. So they generate stuff that may lead to hallucinations, you've probably heard of. And I'm going to show you hallucinations because I want to ensure that in order to be honest with you, the audience, I want to show you that hallucinations come a lot. In everything you do, you're going to see hallucinations very quickly. And speaking of the size of languages as well, researchers have noticed that the bigger the model is, you're going to see new capabilities emerge in that model. So when the model is small, maybe it's going to be able to do some arithmetic and language understanding, but as it grows bigger, it may be doing translations, or even the bigger models can do like explaining jokes. Like you have to really understand what a joke is made of, why is it a play on words, why, etc. And it's pretty crazy. So I tried that on some jokes, and it really does a good job describing jokes in plain English. So the bigger the model, the bigger the capabilities it has, usually. But it's pretty much linear. Sometimes we have the impression that suddenly, because we train it more, it's able to do something, but it depends on how you measure things, because usually it's becoming better at a particular task, and at some point we think it's enough to say, okay, now it's able to do translation, it's able to do jokes, explanations. Since I work for Google as well, but since I'll be showing the PaLM API, I'll tell you a bit more about what is part of Google, Google Cloud, etc., and also some of the latest news we announced related to the PaLM API. So I'm using PaLM 2, which is actually used inside Bard. Who has tried Bard already? Yeah, okay, a fair number. And if I ask the question, ChatGPT, I think I'll get more hands up. Yeah, at least 2 or 3 times more. Try Bard, bard.google.com. It's great. Well, it's pretty good, actually. So it's used in Bard, but it's also used in another product. I'll show you quickly, Maker Suite, which is a product from Google AI, but not part of Google Cloud. So I usually focus on Google Cloud because that's the branch in which I'm working. And inside Google Cloud, there's the Vertex AI offering, which is all the API services around machine learning. So there's a model garden, which is the list of all the models that are available on Google Cloud in Vertex AI. So there's PaLM. There's Imagine to generate image, to create captions from images, etc. There's Cody, which is a variation of PaLM that understands programming languages. And there are also open source well, not necessarily open source, but open language models, which you can also run on the Google Cloud infrastructures. For example, there's Claude 2 from Anthropic. There's, what are the other ones? I think I've got some examples of other ones. It's not just the Google models, you can also run other models on this infrastructure. And then there's a bunch of other things for doing conversations, doing search. The other one I'm going to show you in one of my demos is vector search. Well, no, I'm not going to. I'm going to show vector search, but not the product, the principle of vector search. So this is a database of vectors representing what we call text embedding. So that's the vectors or float numbers that represent the concepts behind the tokens that the large language models use. And then a bunch of other things like Jupyter notebooks, pipelines to do your own trainings, AutoML, ready-made APIs that you can call. And recently, like a few weeks ago, when was that? Like 3-4 weeks ago, a month ago, there was the Google Cloud Next conference, and we announced some new things. So as I said, in Model Garden, there are more models and not just Google ones. So there's Llama 2 from Meta, Code Llama, Falcon from the United Arab Emirates Research Institute, I forget the name, Claude 2 from Anthropic. So there are a bunch of models that you can use. PaLM, the API now has a new version which is able to do a 32K token in terms of the context, the amount of text that you can feed it and retrieve, because before that it was only 8K tokens. And it's actually now for the same price as the 8K model was before. And something to keep in mind, and I don't want to encourage you to use the more expensive model, which is actually very competitive compared to the competition, but don't say it. The 8K model, if you've got a very specific task that you maybe have fine-tuned for your own data set using few shots prompting, etc., you might have heard of that already, or did that already on your own. It's cheaper and sometimes can do pretty much as well as the bigger models. Cody, more performance, better image quality for ImageGen, but I think today, DALL-E 3 or Midjourney are still really, top-notch in terms of quality. So I hope we're going to continue to improve ImageGen to catch up with them. And there's a new thing that was announced by Google DeepMind, which is SynthID, which is a way to do, it's a bit like steganography and watermarking. You're able to, when you generate an image with those models, you're going to be able to say, okay, this was a generated image. So maybe, have you seen the image of the Pope with a really nice, big, fluffy coat? Who's seen that picture on the social networks? Yeah, half of the room. And this one was generated, right? Wow, he would look cool that way, actually. But and now, if the image at least was generated by ImageGen, sorry, you'd be able to analyze the image to know that it was generated by a large language, not large language model, but a big model like ImageGen. And there are other things coming up for data connectors and whatnot. I won't dive into that, which gives me plenty of time to look at some demos. So I'll start with showing a bit of Bard. So we'll use the PaLM API through Bard and through Maker Suite, and then I'll show you some other demos. So let's try, no, I think I'll try Maker Suite first. Maker Suite is using the PaLM API. Bard is using the PaLM API, but then, so I'm not sure if it's exactly the same version, but I think it's supposed to be the same, but it also depends on how you use the API, how you wrap it, because sometimes you may have different results, different outcomes. So for example, is it big enough? What is the name of the first cat who stepped on the moon? Do you know? So if I ask Maker Suite, so let's see, yeah, Félicette. Did you know that Félicette actually is the first cat who stepped put the little pose on the moon. But if I ask Bard, so I'm going to copy and paste this. If I ask Bard the same question, here, new chat, okay, let's call Bard. It's the same underlying model, pretty much, right? And Bard is going to tell me there has never been a cat on the moon. But it's going to tell me about the story of Félicette. Hey, Félicette. It's a Parisian cat that went into suborbital mission in October 1963. So there's been a cat in space, right? But not on the moon. But at least Bard has been, there are various guardrails that have been put around the PaLM API to ensure that Bard is factual, more factual than using a foundation model like PaLM. Although there are some things, for example, if I asked PaLM, even through Maker Suite, to generate some harmful kind of content, it wouldn't allow me, it wouldn't generate. But what I want, it's funny because I start the talk showing hallucinations. Yes, there are hallucinations. And depending on how you use a large language model, you may get, even the same one, you may get different results. But for example, even Bard is not perfect. It's doing a really great job. But for example, if I tried asking, tell me about the DevOps Belgium. I tried this this morning conference, and the answer looks good. But if you look closer, you're going to see some little things that are not totally factual. So there's a bit of random aspect because it doesn't generate the same thing all the time, right? So annual developer conference, Antwerp, so far so good. Lots of Java focus, fine. The dates are correct because it's searched on the internet. It's able, because the model has been trained. I think the last drop of the model was like maybe August, so it's fairly new, or maybe more recent, I don't know. But well, I guess the website was already up, so maybe it didn't search the internet for that. I don't know. I can't be sure exactly. But then you're gonna see things. Yeah, like look at the keynote speakers. Past keynote speakers. Because this morning when I generated that, it suggested keynote speakers, but not all were keynote speakers. So it hallucinated some of the keynote speakers. Well, I won't look at, much more at this example, but there's another thing I'd like to show you that's a new feature. You can click on this Google search button, and it's going to evaluate the response it generated, but also suggest, when it's green, it's going to say, here are websites where you can have a look at to double check, look at Wikipedia, it confirms that what was generated was correct. And sometimes it highlights stuff in orange, meaning that I didn't find relevant information on Google search, so maybe it could be a hallucination. But remember that hallucination is very frequent, right? But sometimes it can be put to good use. And I'm going to show you that in the next demo. Maybe I can show you something else. So there are things that are really great that you can do with large language models. So you can do summaries of articles. You can also extract information. So for example, here, I'd like to retrieve the name, the job, the company of someone's bio. Okay, so I'm going to take my own bio. I tried it this morning. So this is on my website. Okay, I'm going to put it there. So here's the bio. But I want the large language model to generate something that looks like JSON, name, job, company. Okay, so I'm passing this data. And let's see if it figures out who am I. And so name, Guillaume Laforge, job, developer advocate, that's right. Company, Google, yes, that's correct. So that also a great way to analyze, unstructured text and be able to fetch interesting information from that. Okay, maybe one last thing. So I showed you text prompts, but there are different kind of prompts. So a prompt is a query, but you can also do things like few shots prompts. They call that data prompts here. So for example, give me the color of the fruit in input, something like this. Well, I think I don't really need to give it, just giving the query, if I ask for banana, I guess it would tell me yellow, but just to get the idea, so let's say fruits, cherry, red, or vegetables, put of the fruit or vegetable table in input. Let's say carrot, orange, apple. Well, there are apples of different colors, red, green, whatever. Red. I don't know. And then I'm going to put banana, and hopefully it's going to reply with, hey, he was faster than you. I didn't hear anyone saying yellow, right? You didn't know? Right, okay, interesting. So there's this, you can do chat prompts, and you can do fine-tuning. And you also have, I'm not showing this usually, but in the Vertex AI part of the Google Cloud Console, you can also see, so this part is Cloud Run because I'm deploying on Cloud Run, but I can show you, where is it, language. So you've got similar things to create text prompts, code prompts, chat prompts, etc., similar to what you have on Maker Suite. And again, using the PaLM API. Maybe I could just show a model text prompt. Usually, I think there are sometimes some suggestion. No, there's no suggestion. But yeah, you get the same thing like free-form or structured with the input-output. All right, and also some good hints how you want, if you want to do that in Python, curl, but no Java. Interesting, because that's the purpose of my talk, to show that you can, as a Java developer, use this. You don't have to be a Python developer. So let me show you the following demo, because, so I'm not a Python developer. I'm a Java developer and a Groovy developer. Python is a fine language. I'm able to use it a little bit, but it's not really my favorite language. And I started using LangChain, which is a pretty famous nowadays orchestration framework for large language models. But I'm not at ease when I use it. So I was like, okay, I work for Google Cloud. I want to use the PaLM API, but I'm a Java developer, so I wanted to use it from Java. So let's have a look at my first bigger demo, which should be, where is it? Bedtime stories. So actually, hallucinations are great. Why? Because they let you also generate interesting things, creative things. And what I wanted to do was, so now I've got 2 daughters, but they are old enough that I don't tell them bedtime stories anymore. But I thought that was a fine use case. So I created a Micronaut application developed using Apache Groovy, but don't worry if you don't know Groovy, that looks like Java, it's okay. And I deploy that containerized app on Cloud Run, which is a fully managed container service, which is serverless, so it scales to 0 to infinity and beyond, and it's really great and easy to deploy containerized apps, and the PaLM API. So to create a kid story, there are 3 things. You need a character, okay? You need some kind of setting like where the action takes place, if it's in the future, in the past, etc. And then a possible plot, right? So what's going to happen in that story? So initially, because I wanted you to be able to, if you don't have a precise idea of what kind of story you want to generate, initially I came up with 4 or 5 ideas. But then I ran out of ideas, so I asked Bard to generate other plots, other characters, etc. So some are my own, and others are generated by the LLM. So it's kind of meta, using an LLM to generate an LLM use case. But let's say I'm a young astronaut exploring space. Let's say, the sole one that's, or maybe this one, train station, futuristic thing, and mysterious objects in orbit. Oh wait, is there some... okay. And I'm going to click the generate button. And let's see what it generates. So it takes, so I want to use a long enough story, so it takes 15, 20 seconds to generate the story. But normally it should come up pretty quickly. So in the year 2089, humanity has colonized the solar system, etc. So you've got a full story. I'll show you the various steps how I created that. And I used the PaLM 32K model because I wanted to have bigger stories, not just small stories of a few paragraphs. So it's quite long. But I mean, you know, I could have tweaked that. I'll do a few more tweaks. A young astronaut exploring space while attending the DevOps conference. Okay, why not? Belgium conference. I'm going to tweak it a little bit. In a busy train station of futuristic city full of high skyscrapers with gigantic screens showing the keynotes of the, I'll put again, DevOps Belgium conference. And mission to investigate the mysterious object that appeared in orbit around the Earth while Stefan was announcing the movie that is going to be on display tomorrow night. Well, no, it feels weird because it's in the future. Tomorrow doesn't make sense on display in the cinema, where the conference takes place. Okay, let's see. What is it going to generate this time? It's going probably to be a similar story, but there's going to be some DevOps bits here and there. So let's see. It generated some cool stuff. So 2042, technology has advanced. Most popular destinations for space tourists, DevOps Belgium. Wow, I love it. A young astronaut named Stefan. Okay. What else? His friends from NASA, etc. Well, I won't read the whole story, but you can go to bedtimestories.webapp if you want to have fun with it and do some fun tweaks. So I'd like to show you how I implemented that application. So it's in this screen right there. So it's a Micronaut application with controllers. So I've got a controller. I'm using static compilation so that it's fast. I've got a story endpoint that I'm going to call. And I created a special prompt to structure my story in acts, in the 5 different acts. And then the thing was, at the time when I created this demo 3 months ago, something like this, before the summer, and there was no Java SDK that I could use. But there's a REST API that is provided by the PaLM API. So I used the REST API and the REST capabilities of Micronaut with its request builder, etc. So I just point at the right location, the endpoint of the PaLM API. I give it my prompt. I want something a bit creative, so the temperature is between 0 and 1. Closer to 1, it's more creative. Big story enough, etc. And then I authenticate, and that's pretty much it. And then I did some simple marshalling and marshalling because my, so let's see, where is it? So prediction response, it's of type prediction response. Yeah, that was the next tab. So the JSON is unmarshaled into my own classes. So prediction response, it contains a list of prediction, safety attributes, like if it's stuff that I shouldn't be displaying on stage, and the content. That's what I'm mainly interested in. But I can check the attributes to see if the response was blocked in case the content was, questionable. And that's pretty much it. I just make a call to that API, passing the data, and then it's going to unmarshal everything. And then the rest is pretty much just showing the string content field of the response in my application. So that's basically it. So that's fairly straightforward. when you use like a framework, that understands well JSON and that does marshalling and everything for you, that's fine. But still, I was a bit frustrated, and later on, I actually discovered. Let me come back to the slides here. I discovered that the Vertex API, the Vertex AI SDK, now, so it covered the whole gamut of the products and services and APIs of the whole Vertex AI machine learning offering. But they also added an endpoint for dealing with the PaLM API to generate stuff, etc. So I looked at the API, and the API, so I think I'm going to show you that in the second demo, so I can do this. A simple large language model call. So it's a script in Groovy, but in Java that would be the same thing. This is copied pretty much from the samples that we offer on the Google Cloud documentation website. So what I have to do is I have to point to create a prediction service settings to say, okay, this is going to be my endpoint, in which cloud region I'm running, which cloud project I'm using, which provider of large language model I'm using, the name of the model, and then I'm going to, so there's prediction service settings, a client that I have to create with lots of builders, and then those two things, the API that I have to use, there's a predict endpoint. I have to pass the endpoint that I configured there, okay? But then I have to pass two pieces of information, instances and parameter value. So parameter value, that's how I want to customize the LLM model. So, okay, I want this level of temperature, number of tokens I want to generate, etc. And there's the instance, which is the prompt. So, for example, tell me more about large language models. But what I find really ugly with that Java API is that, so first of all, look at this. I have to parse the JSON, okay? But then all those classes, like value builder, value thing, etc., they are actually protobuf objects, okay? So I have nothing against protobuf, but the fact is the API returns, so I get a response, I get a list, I can get the first suggestion. Oh, but it's a struct value, okay? I have to find the field called content, which contains the string, which is generated, and then I have to say it's a string value, but, I would like to have real objects, like in my first demo, response, safety attributes, etc. I want to use real, meaningful Java objects, but I can't. I would like to just say, okay, give me the first element of that list and use the content field, but no, I've got this, and it's very error-prone, if you, I forgot to put string value. I mean, I can't really do code completion or anything like this. So I was very frustrated by this. So, I could, I have time, I can run it. I can run some scripts. So Groovy, because it's implemented in Groovy, simple LLM call, and it's going to say something about, so what was the question? Tell me more about large language models, and it's going to give me, some log4j stuff, and it's going to give me, some information about large language models. Oh, deadline, what's going on? Oh, yeah, maybe I should increase the, can I do that here? Because there's a default timeout but I forget how I can tweak the timeout. So sometimes it can time out. Let's see if I do it again. I didn't try it this morning, so maybe, again, I know what's going on. And I forget how I do to specify a different timeout. But never mind. Usually it works, but this time it doesn't. Yet I was frustrated with this protobuf-heavy API for Java developers that didn't feel quite, natural. So instead, so let me move on. So there were protobufs everywhere, and that was not developer-friendly for me. Okay. But then I discovered a brand new project called LangChain4j. Maybe you've heard about LangChain without the 4j part. Has anyone heard about LangChain? Yeah, almost half of the room. So LangChain is kind of orchestration framework to work with large language models and to also interact with other systems like vector stores, different models, and there are different classes to parse documents, tools, you can parse the output, etc. So there's really a bunch of things, but it's in Python, and I'm not a Python developer. I have nothing against Python, but so I tried using LongChain and get used to do some Python. I've got the bare minimum level in Python, but quickly, well, I didn't feel at ease because sometimes when I use a notebook like Jupyter Notebook with an example, a pre-made notebook, once it works and the next day it doesn't because there are problems of versioning between the various components, whereas in Java, usually, you pin the versions of the stuff you want to use. So it feels more professional, I would say. And I get results, well, except today because my previous demo didn't work because of a timeout issue. But it's not a dependency issue because of the ecosystem which surrounds LongChain and Python. But then, yeah, LongChain 4J, so it was created fairly recently, a few months ago. How much? 4 or 5 months, something like this. And we're going to have, by the way, a talk. Is it tomorrow? Tomorrow morning, we're going to have a talk which dives deeper than I'm going to do on LongChain 4J. But really, it's like LongChain, but for Java developers. And it's a pleasure to use LongChain 4J. And honestly, this is the LongChain logo. And this is the LongChain 4J logo. Which one do you prefer, right? No question, you'd go with LongChain 4J, even if only for the logo and the fact that it's in Java. So I decided to use LongChain 4J. But I wanted to do another demo. And since I'm part of the Groovy community and ecosystem, I wanted to try something. So there's a pattern which is called retrieval augmented generation, which is a way to ground the responses of large language models with data that you feed the large language model yourself. So not something that the language model may have seen during its training. You really feed information coming from the actual documentation. Here, the documentation that I'm parsing, that's the Apache Groovy documentation. So to tell you a bit more about this pattern, let's have a look at how it works. So we've got documents. Here I've got a single page, huge document. I'm going to split that in chunks, okay? Small pieces, small sections, paragraphs, sentences, potentially. And I'm going to calculate, using the PaLM 2 model, I'm going to calculate vector embeddings that represent the various, the semantic representation in terms of vectors of floats of a particular piece. So I'm going to create tons and tons of embeddings for each section of the big document. And I'm going to store that in a vector database that I will be able to query afterwards. And then I've got my user. The user has a prompt, some particular question about the Groovy programming language. And through my app, I'm going to calculate another vector, that is the vector corresponding to that actual query. And I'm going to compare that vector with vectors that have been that come from the documentation. And I'll find the vectors that are the most similar. And once I have that information, so given the context, the prompt saying, hey, you're an expert language, a Groovy language expert or something like this, the user asks me the following query, trying to give an answer to the best of your knowledge with the information that I found on the documentation, because I did a query on the vector DB to return the most relevant snippets of the documentation. And that generates an answer. So I'm going to show you this in, so I've got this huge, big page. So it's really a single page. You can watch the Groovy documentation in multiple pages, but that was easier to parse one single document for me. So I did that. And then I've got this application. So I've got, well, I'll show you just one flavor, but I also have a WebSocket-based flavor and a more stateless version. I'm going to show you this one here. So it's trained on the Groovy documentation. So what can I ask? But PaLM also knows already a bit about Groovy. So I'm never 100% sure whether it really uses the documentation or its existing knowledge. But does Groovy support, let's say, traits and records? Okay, why not? And let's see, it's going to generate to check the vector database. Yes, Groovy supports traits and vectors. Okay, that's cool. So show me and records. Show me a record representing, I don't know, a car maybe. And let's say an example of a record representing a car. And that's where sometimes it hallucinates and doesn't always give me the right answer. Yeah, not too bad. So it did return a record, car, the make, the model, the year. It didn't really need to give me that annotation. It's something specific to Groovy, but it seems to be correct. And it added a bunch of extra methods. So I don't really see some particular any hallucinations there. It even used, well, honestly, the toString method is not really needed, but you can customize the toString method. And it's using the gstring, the string interpolation from Groovy. So it got the notation correct. Funnily, it adds semicolons, which are optional in Groovy, but that's okay, right? So it could be almost a Java record. So it works, and then you can ask further questions. I won't bore you with the extra details. And for this, where's my code? No, my ID is over here. And I actually used, remember the little diagram? There were two parts. The first part was looking at the documentation and generating vector embeddings to store in a database. And then the second part is actually doing the query against the vector database. So, oh yeah, and maybe before showing that, so you remember my example with the Vertex AI Java SDK, which was ugly. The equivalent in LangChain4j, that's just 2 instructions, or let's say 3 instructions. I create the model. I define where the project, the endpoint, the model I want to use, temperature, etc. 1 instruction to builder. Next thing, I'm sending a message. Third thing, I retrieve the text. Just 3 lines of code instead of, I don't know, I don't want to count. So LangChain4j is super simple. But it's not simple just for simple things. For implementing something like the retrieval augmented generation pattern, LangChain4j is great as well. So I did 2 things. A script to generate all the vector embeddings representing my documentation. And then I have a Micronaut application that I containerized and I deployed on Cloud Run because that's a nice container service environment to run your applications on. And so it's just delegating to a service, the query service, which is here. So I'll show you 2 things. So how do I create vector embeddings? So first of all, so there are a few instructions how to fetch the documentation. I'm loading the HTML documentation. I extract the text from the HTML documentation. So it's part of the LangChain4j API to extract text from HTML, for example. Then I'm going to say I want to use the text embedding model. Then I'm going to, well, I'm wrapping that because the API allows me to do only 5 embeddings at a time, so I'm wrapping it with my own class. And it's a contribution I could do to LangChain4j to add that kind of capabilities. And then I'm going to say where I want to store a serialized version of my database. So I'm going to say, okay, I want to split that document into chunks of 1,000 tokens, and there may be an overlap of 200 tokens. So this part, then a bit of overlap between my tokens. I'm using this embedding model, and I'm going to store that in an in-memory vector store, because I could have used any other vector database, but I wanted something self-contained. And then I call the ingest method to calculate and compute everything. And under the hood, it's going to call the PaLM API. But really, there's really just those few steps which are not very complicated. And then I save that in a file, which I'm going to load in my Micronaut application. So this is what this class is doing. I'm preparing a few things like, again, the embedding model. I want to use the embedding model to compare the query of the user to what's inside the database. I'm going to use a chat model because it's a back and forth conversation. I'm reading and loading the serialized version of the vector store. I'm also preparing a prompt. So the prompt says, okay, you're an expert in the Apache GUI programming language. Try to answer this question using the information that is found in the Groovy documentation, in the vector store. And then, so when there's, so the endpoint calls this service, execute with memory. I'm going to retrieve, so this one is stateless, so I'm retrieving the chat memory from a singleton that holds the whole discussions between the various users. I'm going to say, I need a retriever to find vectors inside my in-memory vector store. And then the powerful thing is there, the conversational retrieval chain, which is the implementation of retrieval augmented generation of that pattern, because it says, use a chat model, use this memory, use the template, the prompt template I defined above, use the retriever to fetch vectors that are similar to my query. And I build that, and then I execute that chain, and so it's returning some markdown, but I want to display it in HTML. So I'm rendering, so I've got a method which uses some API to generate HTML from markdown, and I return that in the view that you saw here. So this. And really, I found that pretty straightforward to do, very simple, and much better in terms of Java developer experience compared to what was offered by default in the Vertex AI SDK for Java. So in summary, PaLM 2 is a very powerful large language model. It's one of the 2-3 best models that are available today. So there are all sorts of things you can do with it today. So from a Java developer experience angle, it's not ideal. You can use it, but protobufs everywhere. If you're using a modern framework, maybe you just deal with the REST API, that works as well. Or you use Longchain4j, which is an awesome project I invite you to have a closer look at. And of course, since I work for Google Cloud, use Cloud Run for your containers app. So that's the advertisement in my talk. But well, PaLM actually is probably an advertisement as well because that's Google. But yeah, that's pretty much it. And it's not very complicated to do such applications, really. So I'd be curious to know, well, I'll tell you what I want to build next, but I'd be curious to chat with you maybe after this session about what you would like to build with large language models. But for one thing, I'd like to continue improving this demo because there are hallucinations, and I want to see how I can reduce hallucinations to have more factual responses with the given documentation. And I'd be curious to see how large language model, because of the creative aspect it has, how you can use LLMs to do like news curation instead of spending hours on Twitter, RSS feeds, etc. I'd like to get like summaries of the most important articles that were shared in my network, for example. And large language models are able to do that today, and I found that pretty powerful. So I'd be curious to know where and when and how, and what you have like ideas of things you'd like to do with large language models. So thanks a lot for your attention, and we have like 2 minutes or so for a couple of questions. Thank you. Any questions? So with the light, maybe I won't see you raising your hands. Yeah, one in the front.
Can the architecture of PaLM be used for different tasks than just generative text, or is it just focused on?
Yeah, so can you use LLMs and PaLM for other things that generating text? So here, PaLM is pretty much for generating text, but for example, you can also ask coding questions. Cody, well, it's a variant of the PaLM model, but you can also use it, and it's also integrated in the Cloud Codes IDE plugin that you can use in VS Code, in IntelliJ, etc., to help you as a, like a GitHub Copilot kind of assistant to help you, and not just for generating text, but also for code completion and things like that. It can be used in other situations. Yeah. Any other question? Yeah.
Are there many
Any limitations to? For tokens? Yeah, so like you mean like the context window, the size, etc., or?
No, no. I mean, organize limitation to use price limitation.
Price limitations? Like to avoid using it too much, or?
No, no, no. I mean, what cost?
Yeah, what cost? Yeah, so in terms of cost, it's very competitive compared to the other alternatives. So if you're using, GPT-4, etc., that's usually a bit cheaper than those models. So it's a good choice in terms of price. And also something I'd like to say is that so there's also an 8K model, which is cheaper than the 32K model. But for example, if you fine-tune it, or if you pass few shots, or if you use few shots prompting, you can get sometimes as good results, but for even cheaper than bigger models. So that's something to keep in mind. Without necessarily doing fine-tuning, but even just proper few-shot prompting and such can go a long way also to reduce costs without having to use the biggest model that's available. But for example, for my use case with the kid stories, I wanted longer outputs. So it's better if I use a bigger model with a bigger context window. And then it costs more than a smaller one. But I could have done it differently, like calling it several times with Act 1, Act 2, or Chapter 3, Chapter 4. And there are ways to tweak and work around that. All right, no more questions? So thanks a lot for your attention. Thank you again.